Page 153, example number 3. This example is focusing on how to find a missing angle in a right angle triangle. Okay, so in this word problem they had to set up. The first we're going to do is set up our triangle. So they say there's a telephone pole that is 12 meters high. And again, whenever they talk about a building or pole or tree, we're going to assume it is at a 90-degree angle to the ground. So we know that the pole is 12 meters high, and it is supported by a wire that is 14 meters long and is fixed to the top of the pole and to the ground. So from the top of the pole to one side on the ground, I'm just going to pick this side, it is fixed to the ground. And what we know about this wire is that this wire itself is 14 meters long. So this is a right angle triangle with this side being 12 and this side being 14. And what is the question they're asking us? They're saying draw the sketch to list information. We've done that. And calculate to the nearest degree. So they must be talking about an angle here. The angle between the wire and the ground. So here's my wire. And here's the ground. So they're asking for this angle here. So let's call that angle X. So we're looking for this angle X. And again, whenever we have a right angle triangle, the first thing we want to do is label our triangle according to the angle. So it could be the angle that you're looking for or the angle that is given to you. In this case, this is an angle we're looking for. According to this angle here, we have our longest side always is opposite to the right angle triangle is hypotenuse. So this is the hypotenuse, this entire side. And the other side that helps make our angle is adjacent. And the one that's completely opposite to it is called opposite. Now, the second step is we're going to figure out which one of these trig ratios we're going to use. So in this case, we're looking for an angle, and we have to use the two sides that are given to us. So we don't have much choice. We have to use the opposite and hypotenuse because those are the two given. I cannot use adjacent because I don't know what adjacent is, and neither did they actually ask me to find it. So I have to focus on opposite and hypotenuse. So the identity that works with both of them is sine. Not cos because it has adjacent in it, and not tan, again, because it has adjacent in it. So when I set up this sine ratio, it would be sine of an angle X equals opposite, which is 12 over 14. I could find out what this decimal is, but I'm going to leave it like this for now. The problem is that I have my setup and I could find out what 12 over 14 is. It'll be some decimal number. But that is not an angle. So I did not solve for an angle. So what I got here is sine of X is 0.8571. I'm looking for the angle. My final answer should look like X is equal to this. So far what I have is sine X. So how do I get rid of this sine part? How do I move this so I don't have the sine next to it? So a way to get rid of the sine is we take the anti-sign of this 12 over 14 or this decimal that we got. I would suggest to leave it as 12 over 14, or if you're going to use this decimal number, make sure you use at least 4 decimal places. So I just like to keep it as this. Or if you're comfortable, you can also just use the decimal number that you got. So either this or this. So how do I enter this anti-sign? So in order to do that, you'll notice that all these antis with a little -1 on top of it is on that plastic part of your calculator, and it's in yellow. So it's behind the button for sine, cos, and tan. I'm looking for the anti-sign that's behind the sine button. So I'm going to go use the yellow key, second sign. It will access the things that are on the plastic part in yellow. So what did I do? I went second sign, and it brought up this anti-sign part, and now I can put in what was on the other side, whether in the fraction form, like I'm doing right here, gives me the angle rounded to the nearest angle is 59 degrees, or I could have done by putting that decimal number in, anti-sign of 0.8571. They're both equivalent. One is in fraction form, one is in decimal form, and it gives me the same answer, 58 degrees. So my x is equal to, 59 degrees rounded. Okay, so whenever we are trying to find an angle, we have to use the anti function. Okay, so that is a must.